Good afternoon. Thank you for joining us. We're very excited today to have Dr. Nao Kato, who is coming to us. Is that better? Am I killing you guys? All right. Who's coming to us from LSU. He did his undergraduate work and his early graduate work at Hiroshima University in Japan, where he was in applied biology and plant molecular biology. And then after that, he did a postdoc at Rutgers University before, and actually had an assistant professorship there before coming on to LSU and is there an associate professor there now. So he's going to talk to us a little bit about something very exciting. I think we're all very interested, especially down here, which is the possibility of having biodegradable Mardi Gras beads made from algae. And I have to tell a little tiny bit of a personal story. And the way I found Nao is because my son last year for his science fair project decided he wanted to figure out how harmful Mardi Gras beads actually were, and did a study with Kayla DaCosta in my lab to look at the trace elements and if they come off of Mardi Gras beads when you handle them. And if you guys want to know if that happens, you can see me afterward. You may not be happy about the answer, though. So all the more reason we're very interested in what Dr. Kato has to talk to us about. So thank you.
All right, thanks, Luz, for their good introductions, and thanks for inviting me to give opportunity to talk about Mardi Gras beads. And I arrived here at 10 a.m. 9:30, and Luz showed me this facility, and it was so impressive. Actually, I was here several years ago with my family as a 100% pure tourist, and staying on the beach side, and I actually came here, this facility, but only thing we did was just go to boardwalk, and that's great, and I never think about such a greatest institute is actually behind the aquarium, and it's a great pleasure to talk. So today's talk, six sections. First, I want just myself, who am I and what you're doing, and then a brief history of Mardi Gras beads, and then a problem of Mardi Gras beads nowadays. Luz briefly mentioned what problems now, and then here a possible. Sorry, I have to. Time, excuse someone's help. I know this one is time things. This one, automatically kind of I want to stop.
Are you trying to do the video now, or you want to
No, that time. No. This one's automatically goes through. I want to stop timing. More, no.
Click the use timing box.
Okay, thank you very much.
Thank you.
Thank you. All right, so where am I? So here, possible solutions. A solution. It's not one solution. Okay, I just proposed one possible solution to solve the problem, and then they briefly discuss about challenges to implement the solutions, and then I want to conclude today's talk with current status of this project. So first about me, in the past 2 years, I became a little bit famous persons. Recent here, like internationally known magazines such as Smithsonian's and National Geographic magazine as a pick up stories. I'm not humble persons, but to be honest, I am not such a great scientist. Pick it up like this one. I am a scientist. So here's a little bit about me. I was born and raised in Tokyo, Japan, and I obtained a PhD in 1998 as a molecular plant biologist. And I moved to the Rutgers in New Jersey to do postdoc, and also did assistant professor research, and where actually I apply live cell imaging technique to molecular plant biology to study about chromosome structure in plants. And then I moved to LSU Department of Biological Science, where I'm still there in 2005. And there I actually adding mathematical modeling approach so that I can understand cell function more deeply, and also I can predict the functionality of cells. And then as I see here, I'm not environmental scientist. I'm not chemical engineer to produce biodegradable plastic. I'm really pure cell biologist. And in the year 2011, I make like a hard time to get the tenure, but I just made it. As I said, I'm not a great scientist. I'm a scientist. I just made it. So that's what I mean. And so then once I get to associate professor, I decided, okay, something different. And the microalgae is getting interested in me. And so that's once trigger. Then involving this microalgae study. And the year 2013, we published first a paper about microalgae. And then 2017, now that I apply to the LSU patent about algae-based bioplastics and the method of making. And today's story is about not science much, but about curious life timing and importance of cultural shift. And here, about the curious life timing, so the year 2005, 2013, 2017, which highlighted green, I will mention about why so like this is timing so curious and what brings to work on this project. So here's my member of my lab. So this typical university lab setting, me and 3 graduate students and 2 undergrad students. Now I have another 1, 2. Typical, nothing special. Molecular biology lab, see pipettes here, microwave. So this typical DNA extraction kit, small micro. So nothing about environment, nothing about plastic stuff per se. So I want to introduce a little bit our current project as research-wise. So one of the projects we're doing is cell biology of fatty acid metabolisms in microalgae. So what's interesting to me was showing here. So scientists actually analyzing fatty acid metabolism in microalgae in biochemistry point of view. But what I noticed was not much studies going on about cell biology. So in this typical experiment, so what we did was we apply live cell imaging technique so that we can visualize here fatty acid here and the mitochondria and the peroxisomes in same time in living cells. And as you may know, in eukaryote cells, fatty acid is supposed to go to either mitochondria or peroxisome so that it's beta oxidized and generate ATP and generate energy to survive. But somehow the microalgae fatty acid doesn't go neither organelles like showing here, this combination. If I did time-lapse experiment, actually this fatty acid never go to mitochondria or peroxisome. So this indicating microalgae has more specific metabolic pathway rather than typical beta oxidation pathway. So that's what we're exploring. And another one we're working on was actually applying mathematical modeling approach. So many of you know the microalgae has tactic behaviors such as photactic event, photaxis or chemotaxis. But what little understand is when the multiple stimuli is given to the microalgae, how microalgae decide which directions to go. For example, in this experiment, we perpendicularly give the different gradient. The one's light gradient is here, in this case is vertically, and then chemical gradient, this is typically ammonium gradient horizontally. So in this case, algae has two choices. Following light photactics is one choice, and chemotaxis is the second choice in different direction. So our question is, okay, how microalgae decide when and where they go? And this one, the 3 independent experiment with function of time. So in this specific condition, so what we started finding was algae first responds to light gradient first, so accumulate. So this specific strain actually had negative photactic event, so it goes to dark side. And then recognize there is chemical gradient too, so then start moving to chemical too. So at the end, they just stay, they feel most comfortable. In this case, about 45 degrees, just right middles. So our question is, okay, how this microalgae decide, what the process, how they sense multiple signals to decide their sweet spot. So these are what we're doing. So if you are interested in this research I'm more than happy to discuss after this seminar. So just please let me know. On the other hand, here, this is the main topics today about Mardi Gras bees. So first I want to start with the brief histories of Mardi Gras bees. So actually, Mardi Gras celebration starting here, Mobile, Alabama, in 1703 by the French-Canadian settlement. And then the actually parade started in 1830s in New Orleans. And at that time, actually, people start already giving away. Now, people who knew it so nice. So in the beginning, people give sugar-coated almond to people. So that's the origin of the giveaway. And then what's happening in 1870, then tradition to throw some present to the people who come to see the parade started. At that time, it's like a stuffed animals, some flowers, not bees at all. So that's the origin of parade and giving away, the throw. And the 1870s, so what started 1870s starting giveaway, and when the bees started, so it's saying 1890s, a man, okay, in the parade, dress up as Santa Claus during Mardi Gras. Well, it kind of makes sense, it's all about, Jesus. And then Santa Claus, then he wearing also glass beads. It's a funky guy. Yes, makes sense in New Orleans, right? It's a great place. You can go crazy as much as you can. So that become popular. It's so cool costume. And that's become popular. And then 1920s, then crews began to throw the glass beads necklaces. So that is the origin of what we're seeing now, throw the beads. But at that time, still glass beads. And then at 1950s, after World War II, actually glass beads necklaces become most popular items to throw. So crews import glass beads from Czechoslovakia because that's the Czech glass. It's famous for the glass beads, and then give away. At that time, still the beads are precious items. So people who in the street just wanted to collect and bring to home because it's beautiful. And then what happened was in 1960s, and the plastic beads were introduced, and late 70s, as Chinese economies grow, it's much less expensive one is generated and more imported occur. So as goes, people starting getting more and more and more. And then what we see is now has happened. So from history point of view, Mardi Gras bees, actually the craziness we see now is actually not traditions. It's very young, maybe 20, 30 years old cultures compared to nearly 200 years of history of Mardi Gras celebrations. Then what's the problem of Mardi Gras beads nowadays? So first I want to introduce Mardi Gras beads, current Mardi Gras beads by numbers. This one is good size. So first, weight. So single necklace, okay, is weigh about half ounce, which meaning about 2 dozens of Mardi Gras beads, 1 pound. And the price-wise, so now you can buy beads about 3 dollars per pound, so which calculate about 10 cents per each necklace. Okay. Meantime, it's saying distributors in New Orleans purchase or import the Mardi Gras beads from China as a containers, and that's calculated about $1 per pound. So here there's a difference about $2 per pound. That's how make a profit. That's how economics goes regarding Mardi Gras beads. And then how much we import? It's saying 25 million pounds every year. So which calculated about $75 million sales, and then that it create with about 25 million pounds of beads, which equal to 300 millions of necklaces that we import. And how much is thrown? So that's going to be a hard question. There's no robust statistics data available, but a group of people in New Orleans calculated 50 tons, 30,000 pounds, which equals 700 beads or necklaces per block. Okay, one block, 700,000 beads is thrown. Okay, then how much beads go to the ground and throw away? And it's actually the recent, you may recognize a couple years old news, 93,000 pounds of necklace was found and drain ditch, water ditch. And that's calculated. So basically here, what you can calculate is 93,000 pounds of beads clogged in 5 blocks, and then we know 30,000 pounds of beads are thrown, so which calculates 60% of thrown in Golden Catch Basin. And this 6% does not include amount of beads which are cleaned by cities and moving to landfill. Okay, so it's saying a huge amount of the beads are going to go to landfill. So what are we doing? What we're doing is we pay $25 million to China to dump into landfill, or just clog by itself. All right, so that's kind of a contradict. So first, actually, publicly recognized, publicly telling this story was done by the documentary director David Letterman. He was like a Harvard graduate, and he went to first he shot the scene, craziness of scene of New Orleans. And then he brought that film into China to show the girls who are actually making Mardi Gras beads in harsh condition facilities. And so the movie that you can actually rent in the iTunes now is actually girls in China. They get it. The people crazy in the United States to get the beads, and while they're making it by manually. So this was done published in 2005, starting telling a story about contradict economic or social aspect. And on the other hand, the first time actually negative impact on environment is publicly published. It was in December 2013 by a group called Mardi Gras. The Mardi Gras is a grassroots group which is founded by fathers and mothers who live in New Orleans, Holly and Kirk Grove. And they recognizing what they're doing. It's basically throwing everywhere, and actually they have a little child then recognizing, putting a bees in the mouth, and they, well, what's in there? And no one studied. So there's the first one who studied, and they found actually toxic heavy metals. Lead was in the bees, and it's published, and actually saying we have to be careful. It's harm people, harm land. So this is the first report. And then by 2015, actually enough data is accumulated. Actually, Wikipedia was created, and you can find certain information about how bad Mardi Gras bees are for the environment. And one of them saying here, so basically this saying, bees go to the Pontchartrain and Mississippi River, which drain into the Gulf of Mexico, which kind of we share. Like you sitting here is like our concern. Some impact are there. So actually, the news actually last year season is saying LSU scientists will be scanning Mississippi River for Mardi Gras. So basically, Dr. Mark Benfield, actually I haven't met with him yet, but we have to meet soon or later. So basically, his concerns, yes, microplastics, as you may concern, how this Mardi Gras bees actually involved in this microplastics and how involved in the Mississippi River and Gulf of Mexico. So now I want to introduce a 3-minute short video about Mardi Gras. So who initially starting telling people to rethink the way we celebrate Mardi Gras. Okay, so I want to introduce this nice short videos. So that was the videos about Mardi Gras. So basically saying, yes, it's formed because they want change. It's saying, well, not our generation, but next generation have come to better choice. And actually that video or the photograph actually grab historic moment you may recognize. Here, so David Ledemont, who actually directors of the Mardi Gras made in China, who originally saying contradict of Mardi Gras bees, met with founder of the Mardi Gras, Holly and Clark Grow, in their house to discuss about Mardi Gras problem, Mardi Gras bees, what they can do. So this is a very historical moment. More importantly, I was there. So this one is, as mentioned, a curious life timing. So what happened was, as in my interest of myself, I moved to Louisiana 2005 when the Katrina hit. So because the Grow family from New Orleans, they evacuated from New Orleans and they moved to Baton Rouge, and we met their family in the park by chance. They let to play the kids. We have similar age of kids. We met at the park, and they become a good friend. And they start living in Baton Rouge in several years before they went back to New Orleans. And since we got good friends, we learn about tradition of Mardi Gras. So because as you know, Japanese born and it's never understand about traditions. So we learn a lot. And then one day, hey, come over. We have the Mardi Gras parade. So I came. Okay, I come. And here actually there was a gathering of Mardi Gras that I didn't recognize. So I'm sitting here, and then I talking with actually David. And then I learned first time the problem, Mardi Gras bees, and discussing. And then here, I am a plant biologist, right? So during conversation, it's kind of, hey, wait a minute, that problem, okay, wasting and cannot, go to all drainage, that's a problem. And then I said, wait a minute. Yes, I knew that the biodegradable plastics are available. It's already in the market, as you see here. Like plastic fork and here. You can buy it, even the Walmart they sell. Okay, then after conversation, hey, well, that's easy. Just make it, all right. Right, then but I found was no such a thing, no biodegradable Mardi Gras bees. And I started wondering why. And actually, I quickly learned the reason is here, price. So biodegradable plastics prices range, but reliable ones, okay, most reliable one is about $1 per piece. On the other hand, plastic fork, good one, you can buy 10 cents. So 10 times different. And applying this one, the Mardi Gras bee. So as I mentioned, buy $3 per pound, and that's creating $30 per pound. As I forget to mention, so typically, Mardi Gras crew members spend $500 to $2,000 to purchase bees and throw. So simply 10 times, which means $5,000. At that point, Mardi Gras crew say, well, I want to protect, but no, I have fun. Okay, the human being, I totally understand. And so that's why reason is not technical problem, but here, economic reasons. That's why. And I start studying by myself, okay, why it's so expensive? So here's the reason. So the PLA with polylactic acid is commercially available biodegradable plastic is from starch. And to make the PLA pellet, which is the ingredient of Mardi Gras bees, you start with corn. Actually, the price of the corn per pound is about same as plastic pellet per pound. So starting point, same price. But to make plastic from corn, several steps, is enzyme reaction, fermentation, chemical reaction. So each step ended up pricey. So it makes sense. It's more expensive. So that's why it's not generic, because it doesn't make a profit. And here, again, life timing. At the party I joined was 2013, and if you recall my record, 2013 is the first time we published a paper about the microalgae. And this actual paper's title, it said triglycerol mobilization is suppressed by preferrin A in Chlamydomonas lichardii. So we are interested in how the fatty acid is moving around the cells, and the triglyceride, or TAG, is actually one of the metabolites which has 3 fatty acids joined to glycerols and accumulate in algae. And we use Chlamydomonas because Chlamydomonas is shown here is unicellular green microalgae and used as a model for plant photosynthesis and microalgae the physiology. And also it's used for model for human cilia. The reason is that the flagellus the Chlamydomonas has is very resemble to human cilia, the structure as well as chemical and less bending behavior. So used as models. So as a molecular biologist, I prefer to use model system. And using this one, we're studying about how triglyceride mobilize within the cell of Chlamydomonas. And here, one important player, which is Tony Lam. Actually, he was undergraduate then from New Orleans. And now he's the first generation of family, or first kids who goes to the college. And he's very smart, he's very hard worker. And so I wrote very nice letter for him, and he now currently the 5th year at the medical school in New Orleans. And what I asked Tony to help this project was here. So because we are interested in how triglyceride tags moving on cells, and one paper is suggesting Chlamydomonas accumulate tag by heat stress. And it's about 33 degrees, which accumulate oil, but ambient temperature, 23 degrees, it won't degrade. So idea was, okay, shifting 33 degrees, 23 degrees, so that the Chlamydomonas accumulate tag, degrade, accumulate tag, so that we can monitor how the tags moving around within the cell. So that's maybe a good idea, by controlling tag accumulation and mobilization by temperatures. So I asked Tony, hey, can you check if the literature say true? So what he did was simple. One culture has control, culture 33 degrees high temperatures. Other one is one day 33, next day 23, go back 33. Okay, then analyze how much tags accumulate. And we analyze by a thin layer chromatography or TLC. And tags are supposed to detect here. Experiment they fail. Okay, so what's saying, it doesn't matter. 33 degree high temperature was shifting around, no accumulation whatsoever. Except third day here. Okay, that's okay, both samples, 33 degrees, was switching around. And we scratched here, and then we Tony and discuss, and they say, what's happening, Tony? Tell me what you did. And Tony told me. So here's what he did. So it's simple. Put the culture 33 degrees, and then every day he came to the lab and just harvest 10 milliliters and put the centrifuge tube, and then discuss supernatant, and then freeze at minus 20 degree freezers until analyzed by TLC. So he did other day, except third day. So it's undergrad student, right? He did the weekend, of course, Friday, the party is going on. So third day, he came lab to finish his work, but he rushed to the party. Right? Then he came to the Saturday, and he recognized, wait a minute, I didn't put sample in the freezers. So the next day, fourth day, he pick up the sample, put the freeze at the same time, and they analyze it. And then what happened was that day accumulate. And we say, wait a minute, that's interesting. Right, so we test maybe the stress, no oxygen is available because of pattern. So maybe that's why. Or maybe put the shadows in it. No, nothing worked. Only way we can get accumulated tag is by centrifuge. It's great. It's interesting new finding. So then we start analyzing a tag. So because as I mentioned, tag made of 3 different fatty acids. So we compare what kind of fatty acid in tag, and we compare to chlamydomonas, which culture in top minus N, or nitrogen deficient mediums. So it's known that algae or chlamydomonas accumulate the tag when nitrogen is not available. So that's typically the scientists do the experiment. So we compared that condition. And what we found was, yes, some type of fatty acid is not present there. So which indicating chlamydomonas accumulate tag in different mechanisms compared to nitrogen deficient conditions. And then we also check, okay, what look like inside and here. So this B is a typical view of electron microscope where the tags accumulate here. And here's what happened by centrifugation. So actually it's much dense, which indicating, yes, again, different tags accumulated. And here, bad news for us was here, cell, especially the chloroplast membrane is disrupted, which indicating cells almost die. Remember, this project, we're supposed to switching around, accumulate, non-accumulate, but this data indicating no, cell die by centrifuge. So we cannot use anymore. So basically this project actually end here. Okay, that's great, 33 degrees. Centrifuge accumulate oil. But if you recall that 2013, this is the time when I talked to David. I'm talking about biodegradable plastic. The time I learned it's expensive. And I started looking, okay, what kind of materials are available to make biodegradable plastic? And I learned that tag, which actually vegetable oil, can be polymerized via heat or oxidation, which meaning tag can be plastic ingredient through the heat and oxidation. And here recall the problem is why PL so expensive is so many process involved. So idea is, well, for the Mardi Gras beads, who cares? We don't need a strong one. We just directly make it. And then here the idea, production of crude bioplastic beads with microalgae was born at that time. So idea is, well, once it accumulate algae, it doesn't matter if live or die, just add oxidize and heat to directly mold it. So in theory, because tag is in the cells which accumulate high level, should be polymerized. And I did. And sure enough, yes, looks like. So here, this one is plastic Mardi Gras bead. So basically, I pick it up and then chop it up. And then this one is, I remove the paint. So inside, pitch dark. And here, this one is beads made from 100% algae biomass. It looks same. So actually, I brought the real ones here. So if you're interested, I can show you. And then here, this one that I painted to see if it can paint. Yes, no problem. How strong it is. So this one I test. So I put different plasticizer. So which different adding by different chemical actually physics of this plastic change. With the if I put the glycerol on here, it's more like a rubber, soft gel. And then I put the ammonium persulfate, getting strong, very stiff, the stuff is strong. And here 1.7 megapascal. This is a strength when you throw the Mardi Gras beads with 0.5 ounce from 7th floor of the building, hitting a concrete floor, still won't break. That's how strong. So that's strong enough. Oh, that's great. I can make it. And then also we found this crude biofilter can be compounded or mixed with petroleum-based plastics. So what we did was we mixed the regular plastic with the polyethylene and combined crude bioplastic we made. And then actually the company called Novo Plastic in Louisiana is offer. Okay, we take a risk, use our machine. So the molded plastic piece, it works well. And also this one is biodegradable. So this one, blue line indicating polyethylene basis plate, which is mentioned here. No weight change in the soil. On the other hand, this mixed one is after about 2 weeks, it's swollen up by water, then it starts degrading. That's great. It's biodegradable. And then here I come. Okay, I know the algae algal blooms problem this year. So hey, I can solve the problem like a bloom and make plastics. But actually, I found this not work well. Again, the reason is economies. So here's it's cost to harvest the algae, and also actually most exciting part here, dewatering. So you need to dewater it quickly so that sustain the polymers within the cells. And then we also mix the compounding plastics. And actually the company called Algix in Mississippi already doing this kind of job. The problem is this one won't sell well. The one of the reason is still more expensive. And from health point of view, algal blooms sometimes contain heavy metals and also toxic compounds. So we concern about human health too, and then using this kind of stuff may harmful humans. So it may not work. And then what I learned was actually microalgae produce commercially valuable compound very efficiently. Actually, the company who are starting marketing actually saying in year 2017, $32 billion market for microalgae there. The majority of this market is our nutraceutical and food and supplement. Yes, because microalgae photosynthesize and the carotenoid, protein, so those good stuff. So it's a market. And they're saying by 2026, it's grown to $53 billion market. So actually several companies are starting microalgae business to produce nutraceutical. Learning okay, such a case, how about this? We grow the microalgae not for plastic, which should be inexpensive, but we grow for nutraceutical to make a profit, and then make a bioplastic using leftover material. So then I tested it. Simply in this one, before we make a bioplastic, extracted the beta carotenes and the lutein, which actually has prices is here. It's a good price, okay, compared to plastic price. So here, what I proposed was, hey, here's the solution. We grow algae in Louisiana because Louisiana is one of the best places to grow the microalgae in mainland of the U.S. because hot, humid, good water resource. And then we produce nutraceutical to profit. Then we produce biodegradable Mardi Gras beads for common good. So actually studies showing if company claim something doing to protect environment, actually sales increase 10 to 30%. So if company who doing a nutraceutical supplement saying, hey, we are helping New Orleans Mardi Gras cruise to throw the biodegradable Mardi Gras beads, yes, consumers like the ideas. So grab same supplement, so increase 10%. So therefore, even though Mardi Gras beads won't make any money, or maybe the negative, but still, as a company, use as commercial tool to boosting up their sale. That could work. And then here the patent, and then the actually officer, commercial officer, officer in the LHC saying, "That's great. Hey, you did a good job. Maybe we can announce, okay, with LHC website, so that maybe some of them may appreciate what you were doing." So that was 2017. And then we plan, okay, then we get the interview by LHC staff member, I tell the story, and draft made and say, okay, we publish this one, put the website on Mardi Gras days, okay, in 2018. Here's again, curious life timing. News came, 93,000 pound Mardi Gras beads stuck on the catch basin in New Orleans. That is 2 weeks ago, we plan to announce. And then here, magically, announce, hey, LHC Biologists makes a Mardi Gras bead. So from people who don't, wow, it's great. This scientist great solution within 2 weeks. So that's because that's the reasons it's become kind of a instantly kind of little bit famous, catching up on newspapers and journals. And then I just tell the story. And then here, then people like this idea. So actually, yes, now there are over 14,000 people signed a petition saying we need to ban Mardi Gras beads here unless and until biodegradable Mardi Gras beads generated. That's great. So that's actually also excited some investors. So actually, I get a phone call. I want to invest in your things. I want to pay money for you to produce. And first question they ask, okay, I invest how much I can make. Then my answer is, well, for biodegradable beads, no, you cannot expect any income because you have to compete in expensive beads as they tone down. And then when I talk with nutraceutical companies, they say, why you bother to doing a Mardi Gras beads focusing on nutraceutical product? So it doesn't work. So the only way I learned was, well, one company who do both is needed. So what the challenge nowadays? So here, actually found scales. So here, I calculate large farm acres, which is $1 to $2 million profit annually for nutraceutical product. So it's kind of good stuff. What I learned was investor likes, yes, starting 1 million, they create $10 million. So that's kind of, their mentalities. So that's a good start. At the same time, we produce 50,000 pounds of biodegradable Mardi Gras beads, which is half amount which stuck on catch base in the New Orleans, the half amount. So I have a good start. But challenge here, again, scale. 25 million pounds of Mardi Gras beads come. So even though we start 1 acre, start some profit, start million, less than 1%. So the question is, okay, how much we can make, how much scale we can push. So that's the challenge. So what's the current status? So what we did was, first 2018, knowing working with one company, one side doesn't work well. So we spin off the company called microalgae LLC, which is regional basis, and the company who's selling beads and nutraceutical. Basically saying, hey, nutraceutical company, we try to help local cultures. And on the associate, most is upgrade. So then we starting working with a company called J-Power, which are utility companies who actually isolate special diatoms for biofuel project. And that actually amazing was, actually I visited the one facility and have trouble, contamination problem. So the typical monocultures of microalgae always problem with contamination. But this strain is very robust, amazing, easy to grow, no contamination problem. So this is what we're doing. We're starting small culture and then putting a pool. And this one's 100 acres, so the size. Now we never have trouble. Undergraduate student can do every week, no problem. So it's amazing. More amazingly, this diatom, Phycelia solaris, that produce omega-3, that's oil, same oil, but it's good nutraceuticals. It's very expensive, it's good. And also carotenoids. So this, therefore, we obtain the strain, have contract to grow here in New Orleans, Louisiana. We confirm it works well. And here, now we providing 20-pound algae biomass to Algix. So if you recall, Algix company who already making a biodegradable plastic using algae, and now we're saying, hey, please use our materials. And this company providing biodegradable plastic to Noble Plastic, as I mentioned, they're willing to risk their machine, so they also can design cool Mardi Gras beads and automating all steps to reduce the cost of productions. And then hopefully 2020 we receive the 3,000 just samples biodegradable Mardi Gras beads. And then our plan is in Mardi Gras in 2020 we give away to crew members who purchasing 500. So here, can you tell? Here are the samples. How much you willing to pay for this one? How much you want orders? And then after Mardi Gras, about March, we get feedback and we decide go or not to go as a companies. If crew saying, hey, that's great, we are ordered that 1 million, that's great. But they say, no, it's not cool enough. Then still as a business, it should not work well. So that we are at. And so question is, size-wise, can we do it? 1 acre is not enough. We need 1,000 acres. But that's what we are claiming here. Now, we could do it because here, Louisiana is a good place to grow. And here, Louisiana here, this area too. But a huge aquaculture lands are available, including crawfish, rice field, and a catfish field. So they have problem of the salt contamination. So we can convert to grow the algae. So our diatoms can grow in the salty waters. So this may be another way to work. So with that, today's summary is here. Biodegradable Mardi Gras bees from microalgae were actually invented through unplanned event. Where I didn't plan, I didn't try to rescue, I just, hey, that's cool. So many people involved, I learned the way, so that's the way created. And trying to make the biodegradable Mardi Gras bees viable is not actually a technical problem. The technical out there. Only problem is economic matters. What I learned is, yes, until that makes economic sense, it doesn't move. So that's a challenge. And the more what I learned was maybe not biodegradable Mardi Gras bees, but cultural shift. As I introduced history, this craziness is only a tiny portion of traditions. As we learn and we talk, if we change our mind, why we need catch, or why I need throw the bees, which we don't need anyway. That we can go back, grass bees, cool stuff, right? We just get something, but not 100 or 1 or 2. That may be enough. So maybe the more cultural shift may be more important to protect our environment while the traditions continue in these areas. So with acknowledgement, yes, LSU, of course, my student, that one, the real person who do, I just think, do this, do that, do this. They are doing, I really appreciate. Also, Office of Research and Economic Development, actually they really push, hey, you do, make money with this. So I understand that ones, and I really appreciate the help I got. And also the companies and Mr. Alzur, he kind of my mentor, how business works, because I never in this business field. I learned a lot, and also Missy Roger, who is the president of this company. As I mentioned, yeah, she likes, hey, let's do it. Machine broke, I take a risk. So now it is a great appreciation and hopefully continue to work. And this is a fun resource of this project.